This is 4.2, reflections. So a reflection is the next type of transformation, and it is a flip over a line called the line of reflection. Every point in its image are going to be the same distance from the line of reflection. So what that means is if C is 1 unit away from the line we're reflecting over, C prime is also 1 unit over from that line. And a reflection is also an example of a rigid motion. So the most common lines of reflection are lines like the x-axis or y-axis, right? This line here is the x-axis. This line here is the y-axis. We actually see a reflection in the y-axis in this picture. A vertical or horizontal line in the form x equals a number or y equals a number. So we talked about those in section 4.1. Or diagonal lines, like the equation y equals x or y equals negative x. And we're going to talk about both of those. So what do you think? Are reflections going to be rigid transformation? So since we just see that it's referring to the type of rigid motion, yes. Translations, reflections are both types of rigid. So let's look at our first problem. We're graphing our triangle, and we're going to basically into a section of the line y equals negative 5. So I'm going to draw the line y equals negative 5. So that means it's going to be a horizontal, right? Hoi plus h with y. Horizontal line to y is negative 5. We're going to go down 1, 2, 3, 4, 5. And we're going to draw a line across here. So when I'm graphing a reflection, I'm counting how many spaces it took to get to the line. I want to do that many passes. So for n, it's 1 away from our line of reflection. So 1 passage will be n prime. P, we're going to count 1, 2, 3. So we're going to go 1, 2, 3 for P prime. And M was also 1, 2, 3. So we go 1, 2, 3. So let's list our ordered pairs. So for n, we have negative 6, negative 2. For n, we have negative 1, negative 4. And P prime is negative 2, negative 2. Our next example, we have quadrilateral PQRS, and we want to reflect over the y-axis. So the y-axis, we want to draw it on here, highlight it. The y-axis is this line. Not super straight. Let's see if we can straighten it out a little bit. Nope, not so much. Let's try that again. Maybe make it a little bigger. All right, straightened it out for me. Okay, so we're going to count the number of spaces it takes to get there. So P is 1 space away. So P prime is 1 space away. Q is 2. So we go 2 for Q prime. R was 8 spaces away. So we're going to go 8 spaces away for R prime. And S was 7. So we're going to go 7. So that means I can list my ordered pair of P as negative 1, 2. Q prime is negative 2, 5. R prime is negative 8, 3. And S prime is negative 7, 0. So you're going to try the next two. So the first one you want to reflect over the x-axis, and the second one over the line x equals negative 1. So give them a try, pause. When you're ready to see the answers, hit play. All right, let's check our answers for these. So for A prime, we got negative 4, negative 2. For B prime, we got 4, negative 7. And C prime, we have 5, negative 1. And on the second picture, R prime, we have negative 2, 3. S prime, we have negative 7, 4. T prime, we have negative 8, negative 1. And U prime is negative 3, negative 2. So the next thing we're going to look at is reflecting in the line y equals x. So the line y equals x is a diagonal line, and it has a slope of 1, right? This is in y equals mx plus 3 form. So m is 1 and b is 0, which means it x is 0, 0, and has a slope of positive. So my original point s was negative 1, 2, and s prime is 2, negative 1. My original point G was 1, 2, and now my new G prime is 2, 1. So what I notice is happening here is our numbers are switching spots. So if I wanted to come up with a rule for this, every point that starts gets flipped around. So what was X goes now in the second spot, what was Y now goes in the first spot. And there's actually rules that we could use for this line, for the line y equals negative x, and also for the x and y axis. We don't have to graph that. We could just do them according to the rule. So here are our rules for reflections. So reflection in the x-axis, the x doesn't change, but the y will flip to the opposite sign. For the y-axis, the x flips to the opposite sign and the y doesn't change. For the line y equals x, they just switch positions. And for the line y equals x, they both switch positions and they both change to the opposite sign. So these negative signs don't mean that the answer is automatically negative. Just because something's written as positive doesn't mean it's automatically positive. It means unchanged if there is no negative. It means switched to the opposite sign if there is. So in this problem, we want to reflect over the line y equals negative x. So I'm actually going to use the rule we just said. We're going to use negative y, negative x. So s prime, if I flip them and change their signs, we get positive 6 and positive 1. For t prime, if I flip them and change the signs, we have positive 3 and 0. And then for u prime, flip them, change the signs, we have now a positive 4 and a negative 3. So what that would look like, here's our s prime, here's our t prime, and here's our u prime. Right, so this time our line of reflection was going this way. It was the line y equals negative x. This would be my image and the image coordinates. So you're going to go ahead and try the next two. So in the first one, reflect over the line y equals x. So you could use the rule for that. And the second one, over the line y equals negative x. You can use the rule for that. So pause for the problems, and when you're ready to see the answers, hit play. All right, so for the first problem, our rule was yx. So I'm just flipping the order, not changing any signs. So x prime was negative 2, negative 5. Y prime was 4, negative 3. And z prime was 1, negative 1. For number 2, since I'm reflecting the line y equals negative x, I'm going to flip them and change both signs. So a prime is 1, negative 4. B prime is negative 8, negative 3. And c prime is negative 1, 1. So the point C was originally on the line we were reflecting over, so it didn't change. So anytime you're doing a reflection, if the point is on the line, the point doesn't move. So in the next one, we want to identify the line of reflection. So what I would do here is I would put 2 points that I see are kind of close together, like my B and my C. And I'm going to figure out how many spaces there were between them. And however many spaces there are between them, you cut that in half, and that will show you where my line of reflection is. So from J to J prime, I have 4 total spaces, which means the line of reflection is between those 4 extra spaces apart. And that would put me solidly here on this line, x equals 0, which is also closed the y. In the next one, they are a little different, right? We're going diagonally. So if I count the number of diagonal boxes here, that's 4 boxes, which means 2 diagonal boxes apart would be right here. See how horribly I can draw this line. Not bad, not bad at all. So this line represents the line y equals, ooh, look how the pen is on my pen, y equals negative x. If you're unsure, you can take a test point. B was -3, -1, and B prime was 1, 3. So I noticed they switch spots and both change signs, and that rule belongs to the line y equals negative x. So go ahead and try the next two. You can pause, and when you're ready to see the answers, hit play. All right, so the first one, it was actually one above the x-axis. It was not an actual axis. So that's the line y equals 1. And for our second one, it was the line y equals x. Next, we'll talk about today something called symmetry. So symmetry is when you can map a figure back onto itself. And line symmetry is when you can do that by using a reflection. So the line that we reflect over to get back to the original picture is called the line of symmetry. So we're checking on each of these to see how many lines of symmetry does each one have. And they're all hexagons. So in the first one, I can actually see that I can draw a line straight down the middle. And when I do that, I end up with one piece that looks like this and a matching piece that looks exactly the same on the other side. So I know for a fact that that would be considered a line of reflection. And then if I tried to draw it this way, oh, that's bad. See if I can do it any better. Nope, not really. But we do end up again with a piece up here that looks like that and a matching piece down here that looks exactly the same. So that means this picture had 2 lines of reflection, here and here. If I tried to draw any other lines, I wouldn't have 2 identical pieces left. Right? In the next one, I could do it this way. And because I could do it that way, I could do it through any of the flat sides. And I can also do it through the points, right? I have a half here and a half here. So through every point to every point and every flat side to every flat side actually gives me a total of 6 lines of reflection for that hexagon. And my last one, if I tried to draw a line going this way, this piece here does not match that piece there, so that doesn't work. But if I draw it this way, then it does work, right? The top and the bottom will match. So there was 1 line of reflection, 1 line of symmetry. So you can go ahead and try these, pause, and when you're ready to see the answers, you can hit play. All right, so the first one had 2 lines of symmetry, the second one had 5, and the third one had 1. And then your answer might look very different than mine for draw a hexagon with no lines of symmetry, but that is what I have for mine. There's no line I can draw, and it has 6 sides. And that is our lesson for reflections.